Hi everyone, I'm John Pett, author, speaker, and performer.
And I'm Jeff Sabilico, entertainer, comedian, and almost as much fun as John.
And together, we're on a mission to take you on a journey that explores and reveals the critical elements for you to survive and thrive within the digital transformation.
We will be here to guide you, to engage you, and get you involved.
To take your questions and get the answers from the experts and execs.
So grab a beverage, get comfortable, and get excited.
Because this is MEF
Infinite Edge.
Today, we've got top service and technology experts joining us to explore how MEF standards and APIs enable network service providers to create on-demand, complex, and customized edge-based services with a multitude of ecosystem partners and to gain competitive advantage. Let's go!
Thanks for holding. This is Jeff. How may I help you?
Oh, Jeff, hi. Yes, it's John. I'd like to change my service, please.
Sure. Postal code, please.
That is 91234.
Got it. 93124.
No, actually, it's 91234.
913.
No, 9.
Hold, please.
Welcome back, everyone, to MEF Infinite Edge. I'm John Pett, your host and frustrated customer for episode 8, as we continue to explore another important aspect of the digital transformation taking place around the world. Ironically, the customer experience. As the saying goes, a good customer experience doesn't happen by accident. It happens by design. So, we're uncovering today the magic behind driving competitive advantage and the secret sauce of how great customer services are managed from the edge. How did they do that? It's the question that always follows true excellence. And as a magician, I can relate. I mean, even if I do a simple trick, people usually want to know, how did you do it, right? Or this one. There's one for me, one for you. And that one goes away, and now you have both. How did you do it? Well, see me after class and we can talk, because now we take a peek behind the curtain of today's topic with an impressive lineup of experts from Spectrum Enterprise, Sienna Blue Planet, Cisco, and Equinix. We'll look at how increasing demand across enterprise verticals, including retail, manufacturing, health, and transport, for cloud-native, secure, and automated services is driving an edge services market opportunity for the network service providers, and how organizations that can take advantage of an integrated service-oriented infrastructure at the edge will be positioned to transform. And to what end, you ask? Well, to offer unique, high-value services that address not only changing workloads, but network SLAs and the client experience, providing low-latency fixed and mobile solutions leveraging Sd-Wan, network slicing, 5G, and customer-set security policies. Well, the customer experience is going to be pretty competitive battleground. And this episode, a very revealing piece to the digital transformation puzzle. I'm still on hold. At least it could be good music, but no, not even that. So before we put it in place, let's take a quick look back at some of our series highlights so far. Here you go.
You can imagine that when you get to that level of latency, you can create some truly innovative use cases that allow us to use the network to move workloads at the speed at which the mind processes reality.
The work that we've done, it can be very portable and can be leveraged by other organizations as well, other federations, if you will, other communities and so on. And we have a great example of that with Mobi today.
Business networks, blockchains, ledgers are essentially collaborative tools and collaborative technologies.
SASE services are really expected to provide an optimal combination of networking and security.
Today episode about cloud collaboration, delivering a unified customer's experience with what I'm about to share with you is really spot on this fast pace and strong evolution.
To start with, right, we view our mission to be the world's computer. And we see the combination of 5G, in particular, the eMBB or the high bandwidth mobility offering, together with compute at the edge, giving people access to compute where they need it, when they need it, ubiquitous end compute.
While the standards are there, I think getting the ecosystem to work together, make sure that the expected outcome and slicing performance is extended beyond network borders. And I really think like a group like MEF can help standardize these and make sure they work well.
Networking is cool again, right? Networking is cool again.
Time flies when you're having fun. A very nice cohesive summary of key takeaways from episode 1 through 7, and all available to you, our audience, right here on this platform, and now also on YouTube. Of course, it wouldn't be possible without the continued and generous support of our sponsors, speakers, and analysts. Once again, a huge thanks to them, and please feel free to show your own appreciation too by visiting sponsor booths below and connecting with our speakers and analysts in the chat window. All right, I'm still holding, so let's hit the ground running today with a very special keynote presentation from Gunnar Peters, VP Enterprise Services Innovation at Spectrum Enterprise, as he tackles transforming the customer experience from the service provider standpoint.
Thanks, John. I really appreciate the opportunity to discuss a key and particularly relevant topic focused on edge compute, specifically how service providers can offer enterprises the capabilities and expertise they need to address their unique needs. As a MEF community, we cover a lot of ground on various technologies, but one key aspect that ties everything together is how we can provide enterprise clients a competitive advantage and help them along their digital transformation journey. In previous sessions, we've covered a lot of the technical-oriented topics. So in today's session, I would like to take the enterprise client's perspective and speak to how the edge can transform a client's ability to deliver a great customer experience and share key use cases that the edge can enable. Some of the key elements we often discuss in context of the edge computing components are efficiencies in operationalization, workload distribution, and the ability to instantiate new or augment existing services to tailor them to client business needs. These elements can be complicated for an enterprise, so they rely on service providers to make it happen behind the scenes and make the experience for their customers seamless. And taking complexity out and simplifying how end users consume a service is how enterprises look to differentiate themselves. While walking through Breckenridge, Colorado the other day, I spotted a sign on a window of a Patagonia clothing store stating, "Innovation isn't always visible." Now, granted, a clothing store is not the vertical we associate immediately with innovation. However, it made me think about how applicable that concept is to the enterprise client in the context of services and, more importantly, how we deliver these services to our clients. Edge compute is one of the technology components that we have to consider as part of a larger and overarching goal that enterprises are focused on these days, and that is digital transformation. Digital transformation is the journey to modernize their IT infrastructure to address the way they do business. This is where clients focus on leveraging automated processes, leverage data insights to make business decisions, and taking advantage of a range of technologies and innovations from running applications closer to the edge for performance reasons to leveraging the cloud infrastructure to more broad workload deployments. All with the focus on increasing operational efficiencies, as we just talked about, and creating a competitive advantage for their business. And as service providers, we're well positioned to assist and guide our enterprise clients through that journey. There are some amazing opportunities and advancements with the edge, but where are the clients in their digital transformation journey? Based on some recent surveys that were done by IBM across companies in the US and the UK, when they look at clients or enterprises, a lot of them might not be quite ready to take full advantage or know how to start that journey towards digital transformation. Let's look at the statistics. 60% have doubt that their organization is ready to address and implement these services. 24% are only just starting to take the first steps. And about a one-third surveyed say they are still in the midst of a transformation. Given these results, these organizations also indicated that the cloud has definitely been one of the key drivers as part of that transition to focus on implementing a scalable digital business. The cloud tends to be an initial starting point because of its low barrier to entry. This also drives the need to focus on areas such as professional skills development as well as security upgrades within the enterprise. To accomplish this transition and move towards IT modernization, a lot of these organizations, more than 3 in 4 surveyed, say they will rely on a trusted partner that can provide them the managed infrastructure services. And Spectrum Enterprise is assisting our clients with that journey, with managed, co-managed services and security solutions, just to name a few. The opportunities presented by developing the edge services for enterprise clients to meet their current needs as well as future objectives puts our industry on the cusp of an extremely exciting and innovative period. Digital transformation is no longer seen as a choice for the enterprise, and the edge plays a key role. However, you can't just look at the edge compute component in isolation. It's part of the larger ecosystem. How do we enable enterprises to take advantage of the edge capabilities and its service-oriented infrastructure in order to build and offer differentiated services to their customers? As we look at the edge and what it means to the enterprise, we define it as the edge can span from the customer premise all the way to the edge of the network, from leveraging hardware, software, or even universal CPE that allows for specific functions to be deployed to run services closer to the edge, all to allow the enterprise to scale, manage, and improve the overall application performance, and to reduce latency for services at the edge. In some instances, enterprises can take advantage of integrated AI, ML, or take advantage of storage, performance, visibility, and of course, security components. Next-gen use cases may want to explore the benefits from the edge that may not be totally supported in a more centralized cloud-based deployment. And again, service providers are well positioned to deliver the edge with services, infrastructure, and a key factor, which is the network. According to IT analysts, digitization is happening in 3 main areas. The first is the core network, which IDC defines as a cloud or traditional data center. The second is the edge, where infrastructure often runs applications closer to end users. And the third is the endpoint, like a computer, smartphone, or connected device. As service providers, we have to take a holistic approach to addressing the enterprise need in connecting and controlling all of these aspects of their digital journey by aggregating, integrating, and simplifying multiple technologies under one umbrella or solution. Too often, enterprises just focus on hardware and software, running their applications in a data center, just the edge or the endpoint, without giving adequate attention to the network that enables them. Both internal and external collaboration are enabled by the network. And without investing in network modernization, the investments in next-generation hardware and software will not deliver on their promise. Network modernization is foundational for the attainment of digital transformation, creating opportunities and unlocking challenges for an organization. A service provider with deep networking knowledge and expertise enables organizations to keep pace with advances in network technology. Instead of reacting to new developments, organizations can proactively allocate resources to their advantage, embracing advances in IoT devices, and collaborate with customers on their terms without worrying about details to enable workloads where they need them. Organizations of any size can benefit from understanding and implementing these technologies, and more importantly, selecting a service partner who can assist them with this transformation. As you can see from the quotes and the announcements that are prevalent across the industry, and we see those almost every day, the edge can play a significant role in addressing these needs for the enterprise, and it's fueling the fire and creating expectations for many associated opportunities. The market and arguably enterprises expect a significant impact from edge compute's low latency performance capabilities for applications, IoT services, or workflow. At Spectrum Enterprise, we provide clients with a range of solutions, services, and guidance to facilitate the implementation of their solutions from the edge to the cloud to meet their business needs, where, how, and when they need them. Given the focus and the need for organizations to incorporate these benefits of the edge into their organization's future, there are a number of use cases that can play a role in that transformation in a range of verticals. The first one, of course, is hospitality industry. As they return and look to establish a new normal, they're turning to technology to transform the guest experience. And the combination of AI, ML, and security integrates both of these components. From physical to virtual security implementations, hotels have a number of use cases where edge compute comes to play. One of those use cases is focused on leveraging camera-based solutions to capture, anonymize the information at the edge, leveraging edge compute with integrated AI and ML. only metrics are used and privacy is maintained, and the services can make a fast and appropriate assessment at the device edge. If you look at the healthcare space, there are so many use cases where edge compute and the client experience intersect. Let's look at the MRI imaging as a function in a hospital environment as one use case, delivering the ability for doctors to shorten the time to review and address patient needs by leveraging portable scanners. Another use case is patient monitoring and safety. Falls of patients in hospital or nursing facilities carry significant impact both to the patient's well-being as well as to the length of the recovery. The CDC estimates that in the US alone, falls among adults 65 or older are very costly. Each year, about $50 billion is spent on medical costs related to non-fatal fall injuries. There are three solutions that can have a big impact across this industry. First is leveraging edge compute in conjunction with IoT devices to capture metrics along their particular vitals. Second is using patient monitoring to prevent falls. And the third is improving the patient's experience with patient alerts and fall prevention systems that can have a big impact across the industry. These solutions live and are enabled at the edge. Earlier in the year, Spectrum Enterprise led and presented the MEF proof of concept in partnership with ADVA, Juniper, and Equinix, with a focus on revolutionizing the live event experience, essentially changing the ways the fans experience a game or concert, both in and out of the stadium. In this proof of concept, edge compute is viewed in context with cloud-based deployments, as does go hand in hand. To deliver that type of live event experience, we explored various technologies that would be leveraged to deliver that differentiated customer, or in this case, fan experience. For fans in the stadium, we leveraged 4K cameras, edge compute with AI ML, and private LTE to deliver the content to the fans in the stands. This really provided a great example of what edge compute can enable. Additionally, for fans outside the stadium, we looked at leveraging some of the emerging technologies and working drafts from MEF around network slicing, Sd-Wan performance zones. This combination provides fans with a game-changing experience and allows them to be their own producer of their content. Our client experience transformation themes were informed by data about what clients want and how edge can play into that particular experience. One of the key components there is optimized communication at the edge. It improves the application performance, and in this case, in the stadium where the application delivers an interactive and high-performance client experience. Second aspect is the orchestrated experience, right? Interactions are seamless, and AI and edge compute allow fans to select their views based on their preferences. And the third component is the effortless interactions, keeping interactions simple in ways that are convenient for the fans to consume the content. As we've indicated, the client experience is foundational and drives the approach as to the technologies, the infrastructure, and improvements we look to leverage in implementing services for our clients. Each of the following tenets has underlying technologies and capabilities that support these changes to modernize systems and the network at the edge. Let's look at all three tenets individually. The first one is simplification. Providing the clients the ability to decide and address their specific business needs is critical, and making that process simple is key to that success. It's important to meet the client where they are and help them achieve their future objectives by offering them the ability to leverage a self-service or a managed solution and have that service run in the most effective environment at the edge. The work that MEF has done and continues to spearhead around LSO and the ability to orchestrate various components within or even across service providers is critical to make that appear seamless. The second component is improving performance, right? With these new technologies comes the expectation that the client that things get better, particularly from a performance perspective, which is a critical component of why clients want to run services at the edge. As a client, I need to assess what's going on with my network and my service at the edge, so I require visibility into the metrics and allow me to drive my decisions based on data. Bringing AI into that approach can make my decision process even more integrated and automated. As we discussed in the previous slide, the trusted partnership is key to delivering and assisting clients in their journey. Spectrum Enterprise serves as a trusted partner to our clients by delivering services that are application aware and move towards intent-based networking. The third tenet is flexibility. It allows enterprises to address changes in their business as well as differentiate their services for their end customers without having to think about where to run these workloads. It also allows enterprises to pivot to new use cases and take advantage of technologies to address new, effective solutions around IoT devices, sensors, smart applications, and resilient solutions, just to name a few. So in closing, leveraging the edge provides clients the technologies and the services to jumpstart or realize their journey towards digital transformation that creates new progressions that weren't possible previously. The MEF community plays an integral part in paving the way with standards that service providers can build on and bring organizations together via partnerships in venues such as this Infinite Edge series. These are exciting times for our clients and the entire MEF community. We have the opportunity to transform the world around us, but that requires focus on that which is not visible to enable that which is. Innovation isn't always visible, but all the behind-the-scenes innovation builds to something that is visible and makes a significant impact to supporting digital transformation. And digital transformation is what drives the differentiation of services that we provide to our clients. Thank you.
Great job, Gunnar. And thanks to you and Spectrum Enterprise, a MEF 3.0 certified provider, for jumpstarting our discussion today with an informative look at service provider challenges and opportunities in transforming the customer experience.
If you'd like to pay your bill, press 1. If you need technical assistance, press 2. If you'd like to speak to a customer service agent, press 3.
No.
For English, press 1. Para español, presione el número 2.
Thanks for calling. This is Jeff. How can I help you?
Oh, thank you. Thank you. It's John. I'd like to add a service.
Absolutely. Happy to help you with that. Hold, please.
What? Oh, come on. What? Shifting gears to the Analyst Corner, we continue with market insights and research data from Cliff Grossner, Principal Single Shot Consulting, and Dalia Adib, Director Consulting and Practice Lead, Edge Computing, STL Partners. Cliff is a 25-year plus industry veteran covering data center, IT, and networking, currently an independent industry veteran. In addition, Cliff is active within OCP Futures Technology Initiative and a member of the program committee for the OCP Future Symposium, as well as chairing the High Performance and Hardware Acceleration track. Now, Dalia is an experienced strategy consultant currently working at STL Partners, a boutique research and consulting firm focused on the telecoms and technology industry. They explore how the sector can derive real value from innovative technologies such as AI, 5G, and edge compute. And notably, Dalia was shortlisted for Edge Woman of the Year in 2019. Cliff, Dalia, I welcome you and turn it over to you.
Hi, Cliff. Really looking forward to our session on Edge.
Yes, Dalia, great to be talking with you again, and I'm looking forward to a vibrant discussion. I wanted to share with you and hear what you think about the fact that I still think there's confusion out there in the marketplace about what is edge, and even unfortunately, I still see some what I call edge washing going on.
Yeah, I think that's fair enough. It's still a gray area, and I don't think any analyst would claim to have a completely succinct definition of edge. The reality is that a lot of things that used to not be called edge computing are now falling under the edge umbrella. So an example of that are regional data centers. So this idea of moving fairly large compute power to a more regional location. We're seeing a lot of investment happening in Europe, in tier 2 cities there, in new countries, new cities in Asia, and also in the US as well. A lot of tier 2 city data centers popping up. So that's a form of edge. There's a lot going on in the telecom space, and we tend to refer to it as network edge computing. You might have a different term. And that's really the idea of the telco operators and others putting edge compute in their network facilities. And then you have kind of on-prem enterprise edge, and that's really about putting compute capacity at the enterprise site, which could be a factory floor in a manufacturing setting. It could be a retail store. It could be a shopping mall, shopping center, lots of different places. And then the last level, which is the most edgy of them all, is really putting more edge compute in the end device itself. And I've seen examples of that starting to happen in the video camera space, where you have this idea of smart cameras, so the camera itself not only being able to collect data, but actually start to do some of that processing and act as a compute platform. But yeah, I don't know what you think, Cliff. Does that resonate with you? Is there anything you think slightly differently?
It does actually, and to add a little bit to what you said, for those of us that like to quantify things, there's a couple of different measurement systems out there that I think are also worth noting. One is the use of round-trip time from user to compute platform of 20 milliseconds or less as one way to say, okay, this is an edge location or it's not. I've seen others have a grid where they use latency versus available bandwidth to decide if something might be edge or not. And then, of course, there's also the open source definition put forward by the Linux Foundation that really defines only two types of edges, the cloud provider edge and the user edge. And they further subdivide the user edge based upon device type. And I think, all of those edge definitions are valid based upon what you're trying to achieve. And I think it's also important to keep in mind that edge is really a reversal in some sense of the data center consolidation trend, which was kicked off by the desire to use enhanced AI and ML techniques, which need high performance compute over large data sets, and that really can't totally be achieved in the cloud, right, in a centralized data center. Now, I've also seen some of the work that you've done around use cases, and I think it's quite exciting. And so maybe you could help me try to understand a bit some of the use cases you're seeing before I share a few of the ones that I've come across in my research.
Yeah, sure. I think there's a lot of interest and exploration happening in the industrial space. So I'm not sure how familiar you are with the term Industry 4.0, Industrial IoT. There's been this general trend in sectors like mining, oil and gas, manufacturing, even warehousing to change how the industrial processes are kind of designed and architected and what infrastructure they use. And there's this term around IT-OT convergence, which is really about bringing IT processes, operating models, innovation models, and infrastructure to the OT, to the operational technology floor. And what that means is that it, rather than having some core OT processes being conducted in a bespoke or proprietary piece of manufacturing equipment, the idea is that you could offload some of that to a nearby edge compute. It's still, that's still early days. The idea of taking say a robotic piece of machinery's control system and processing that outside of the core machine is probably a while away. I would say, at least 5 years out from us getting past proof of concept stage, because, you're having to design something that works in all scenarios, that can comply with health and safety as well, that can provide a mission critical application and performance. But there are some early ones. So some interesting ones I've seen are a lot about computer vision, using video analytics. So using video sensors now to augment general IoT sensors. And that's really interesting for kind of quality assurance. So during, say, the manufacturing process, you want to be checking, is the product that we are producing, does it look right? Does each component look right? Is the machine that's conducting that manufacturing process working in the right way? And being able to detect that in real time is hugely beneficial, because if something goes wrong and the manufacturer starts producing defective products, that's millions of dollars wasted at the end of the day. Not just the costs that are wasted, but you might have customer complaints down the line. There's a whole host of things that really make the business case. So seen a lot in the industrial space. And that's interesting. And back to our original question around defining the edge, we did a research study recently speaking to a few enterprises in that sector about which edge would they use for those types of use cases. And it really varies. So you have some customers, some enterprises using existing data center infrastructure, which do exist in large manufacturing sites. Some are using these kind of micro edges, like a little containerized box, which is running of some virtualized infrastructure and the applications. And then you have, kind of things in between. So it's really exciting, but it's definitely not straightforward. So I'd say that's an interesting use case domain that we've been looking at.
Well, that's great. And much of that really lines up with my research as well, especially around the manufacturing area. One of the things that I might add to that is the gaming area and bringing in the AR, VR, which a lot of gaming platform providers, I think, are looking at and investing in quite heavily. And we've seen some success there so far, although that's more of a traditional IT environment, admittedly, but still needing to move, depending upon your definition of edge, need to move that closer to the end user. And then we've also heard a little bit about immersive experiences in Stadia and things like that, changing the experience of being in the Stadia once we're allowed to be there again, hopefully in the near future. And then, of course, it wouldn't be complete, I think, to have a discussion about edge computing if we didn't mention mobile devices connected over 5G as another important emerging use case. And also, I think a lot of people think very quickly about the public network, but also there's a lot of private networks being rolled out, potentially 5G type. So I think those are some of the other ones that I would add on top of those that you were mentioning.
Yeah, I think that's a fair point, because 5G is not only going to be a catalyst for some of these edge use cases, which will use 5G as the access technology. It's happening with private 5G networks, which is allowing these especially these industrial sectors to innovate and access some of these edge use cases and do things differently to what they do today. I think the venues one you gave is a great example of some of the events. But I think with 5G that's interesting is it's also a use case for edge, right? Because of the the virtualization that's happening, and the 5G core, for example, is it's software-based in nature, which is different to previous generations. It will use edge compute infrastructure. RAN, the access network, is also moving towards that model of virtualization as well, containerization. And so with the telecoms industry, it's both a consumer of edge and it's also potentially a provider of edge as well.
Well, shifting gears a little bit, I was wondering what you were thinking about the top business drivers. So we've talked about, the end user experience. What's the business reason that you're seeing for some of these changes?
Yeah, I think it depends a lot on the use case. So if we take the first few that I was describing around the industrial space and this idea of using videos as a sensor and the IoT, they're the driver for using edge computing and processing data more locally is a few things. One is being able to reduce the amount of data that has to transport over a very wide area network, and moving data to a central server or cloud can be very costly, particularly when it's high bandwidth, real-time data. So that's a real benefit that comes with edge. If you can process it on site, then you can only take back what's really needed to be stored for the long term to a central server or a cloud. The other thing I think in those scenarios that comes up a lot is data privacy. And so to some degree, there's been a barrier to adoption of cloud-based IoT technologies in those sectors because they are often designed to run in a public cloud or in a remote cloud. And many enterprises in sectors like oil and gas and manufacturing have quite strict sort of guidelines and policy about where they store operational data, and they need it very much in their remit and often on site as well, and complete and physically quite separate from any other network or any other partner, customer, competitor, whatever it may be. So data privacy is often a reason, and by putting edge compute, you can keep that data within your premises. So that's for those types of use cases. Then you talked a little bit about gaming, right? And augmented reality, virtual reality. Well, to be able to offset what tends to run on the VR headsets, all that processing that happens to generate a really rich image. If you want to render that on an edge, you need a very, sort of sub 10 millisecond latency between the headset and the edge, so that the person who's wearing the VR headset doesn't feel dizzy, that they're able to look at something in it and kind of have a frame of reference and see something that's real and kind of high definition. So that's more of a latency play, I would say, for edge. to be able to do that. Similar thing with gaming. It's really about reducing the latency between gamers and reducing the latency that comes with cloud gaming as well, which is a kind of a trend and a business model, I suppose, that's coming through in the gaming industry. I would say those. I'm not sure if you've seen some other business drivers though. I've probably forgotten a few as well.
So we've definitely seen all of those in spades. And in fact, one company that I'm on the advisory board for who started doing telematics maybe 10 years ago, and today their systems are all centralized. The first thing they said when I said to them, you need to start to look at this edge computing technology was, wow, we could save more than 30% of our bandwidth costs by moving some of the compute closer to the edge pretty quickly. So that supports what you were saying there. And the other ones that I've heard about around public safety monitoring, analyzing the video and behavior of people in real time to see if someone's doing something suspicious are some of the ones. And the last one that we shouldn't forget is, especially for the telecom providers, is to provide new revenue streams for them through new applications.
Yeah.
And I think those are the...
Yeah, there's some of the drivers. Sorry, just thought of another. So I think the other thing is flexibility, because in the past, infrastructure has been quite static and rigid. So you brought up the venues and the events example, I think, before. We've seen some proof of concept happening with I guess quite mobile events. So an example would be, these racing tournaments or even golf tournaments that happen once a year in a certain location. And often the event organizer has to kind of carry their infrastructure with them, no matter where the sport is occurring, where the event is happening. And there's various amounts of, there's various applications, I guess, and systems that use that compute infrastructure. I think, what we've had is what would be great is if they had access to an elastic edge compute, which is likely to run maybe in the network edge or maybe in an urban location, a nearby sort of edge data center location, and allow them to basically have that ability to move their workloads no matter what country they're in, no matter when the sport is running, and only pay for what they use. So it's more of a commercial reason. It's that they don't want to have to pay for the infrastructure that's fixed and have to move that and pay for the transport cost, as they move their event. And also, there's a lot of just maintenance and logistics that go around having to do it that way. So I think that's quite an interesting use case with a slightly different business driver as well.
In fact, Wimbledon tennis tournament is a great example of that.
Yeah, they have a huge. This might stretch my knowledge, but I think they have a huge, essentially computer underneath the stadium, if I'm not mistaken. So, and that must be hugely costly to maintain. But maybe it's time to offload that to a nearby edge compute.
So I think one of the other topics that was really important that we said we wanted to talk about and is the idea of the cloud versus edge versus IT ecosystem.
Yeah, and I know this is something that when we had the discussion beforehand, you've kind of almost highlighted there are these three ecosystems coming together. So it'd be great if you talked a little bit more about that around where those ecosystems are starting from and how they're sort of converging together, I guess.
Yeah, and I think what I would like to do is share with people a bit of what we've seen happen in the last 5 years around distributed computing technology, which has totally changed the game with the adoption of software containers and Kubernetes. And what's really happened is now we can build software that's constructed using hundreds of components that are lightweight and can be developed very quickly. And effectively, people want to write once, run everywhere. Well, now that we have the capacity to deliver a use case that with coordinated workload components deployed where they need to be from a centralized data center to the edge, creating an IT ecosystem that is breaking down the cloud versus edge silos, we now have to think about an IT ecosystem and stop thinking about, is it cloud, is it edge? It's really all of that in a coordinated fashion. And I know that the hyperscalers have been doing a lot to get engaged in the game because of that. And I think you had mentioned earlier that you had been doing some reading on that.
Yeah, I mean, so the hyperscalers are huge, right? And they are supporting different industries with different offerings, and they're moving into the edge compute space. But I agree, what's happening in telecom specifically is new, and it's part of that whole trend to change the value chain, right, which we talked about. Each of the hyperscalers is taking a very different approach. You have Microsoft, who's made 2 huge acquisitions in the telecom space through MetaSwitch and Affirmed, and are providing more of a full stack offering because they now have the network functions, the applications to take to market as well. But they also have, they've got variety in their offering. They've got the pure infrastructure play. They have in some cases more of a sort of a software play. They're looking at private networks. They're looking at the public network edge. And AWS, Google, IBM, they're all using their heritage in hyperscale compute, and now kind of altering it so it's ready for the networks. I think the reality is that, we've spoken to a few telecoms operators. It will take time to change how telcos run their network and the infrastructure choices they make. Just like we saw with virtualization, we've been talking about it for 10 years plus now, and it took some time to kick in, and 5G now is accelerating that. So I think also this idea of changing the value chain, changing how networks are built will take time, but there's definitely been some interest. And we recently did a survey to kind of find out from the telecoms operators how much of their infrastructure was going to come from hyperscalers across different domains. Some of them being, to run their edge compute applications and platforms. Some of the domains will be more networking, so to run their core network infrastructure, RAN network infrastructure, private networks. And the area that came out on top actually for hyperscaler support, one was edge compute at the network edge sites. So that's more to support the applications. But some of the other areas which were a little bit higher than we thought at this stage of the market maturity was also distributed core network functions. And they felt that hyperscalers to complement their edge platforms, they could provide infrastructure to run and host their distributed core network functions. So that we are bound to see more of that. But I think that's really changing. It's definitely changed the relationships that telcos have with hyperscalers, but it's hugely complex. And I think there are still some open questions about where do we work with them, where are we competing with them, just like there are with their other partners as well.
It's interesting what you're saying, because I've been telling anyone that would listen to me for the last several years, since the public cloud, or the competition between on the public cloud has resolved itself between the cloud providers and the communication providers, that a new ecosystem had to evolve, that it couldn't continue the same way. And that, we have the cloud providers with a stable of customers running applications over the top. And we have the communication providers that had a similar stable of customers where they own the last mile. And when you look at edge computing as it's emerging, that's a hugely important piece of real estate, however you add it up. And so it's really with edge computing that the communication providers have a chance to, if you like it, get back in the game, as far as I'm concerned, in the market, and leverage their sought after edge computing real estate. And as long as they, as you said, are careful about the challenges, that they, leverage innovations from the cloud providers rather than try to duplicate everything, especially around AI and ML and automation, that I think there is a new ecosystem springing up where there's enough cooperation to make it viable. And that's what we're going to see. And in fact, it begs the question, right? What is the role of telecom operators moving forward? And, if we look forward 3 or 4 years, is Google different than, I don't know, pick your telecom provider?
And I think it depends a lot on which telecoms operator. There's, each has a slightly different strategy. Some prefer to focus on their connectivity business. Others are looking to, move up the value chain, looking to consolidate a kind of compute. I think one of my colleagues, David Marr, talks about a net compute offering where they, bring the two together. And yeah, each approach is slightly different, and that will also determine how they work with the hyperscalers as well, because I think in some cases they see them as competition, and in some cases, they're more than happy to work with them because they're a great customer or they're a great partner for them to roll out these state connectivity services.
It'll be great to circle back with you in a year from now and see what happens with the Microsoft AT&T deal and how that really worked out.
Yeah. Yeah, no, definitely. And I think, the other thing with telecoms that we've heard in terms of we've interviewed a few enterprises, and we ask sometimes the question, what's the role of the telecoms operator? Do you prefer to work with a cloud provider, telco, others? One thing that does come up is the idea that, first of all, the telecoms operators are a local partner. Another thing that comes up is this idea of trust, and that they have secure networks, this idea of security. I think something that we haven't talked about probably in the analyst community yet as much is how you secure the edge. What does that mean? How different is that from securing cloud connectivity today? So I don't know if you've got any specific thoughts on that point around security.
I do, actually. I usually have thoughts on many things, and
I can count on you, Cliff.
Many of the vendors that I talked with actually talked to me about physical security, and not for a data center building, but actually for publicly deployed facilities. Like, I do believe there's a project that's in the public domain around 3,000 street boxes going in Barcelona, and there's a lot of work being done to add GPS locators into the server, so if the server gets moved, or Mercury switches if it gets tilted, or anything like that, that server becomes inoperable and the data gets wiped. So really to protect the physical devices itself. But then we also need to look at, if we look at the IT side of things, the entire hardware software stack. And I start right at the bottom with a hardware root of trust for the components, so that all the components in the device are identified and know each other, and you can tell that they have not been tampered with. And then we need that root of trust to move up to the firmware level, where any firmware upgrades and any firmware needs to check out, and we need to know that it's not been tampered with. And likewise to the OS level, that same root of trust has to go all the way up to the OS level. Then, of course, we get to network security, which we've all talked about time and time again, and that needs to be embedded in the communication components of the device.
Yeah.
And then when we look at the application stack, we also need to rely on having proper identity management and key management, so that anybody accessing any of the applications that ride on top of all of that is identified properly and has the right access policies applied. Those are my first thoughts on security.
Yeah, no, I think that makes sense. I haven't looked at security in as much detail. I think one area that's interesting is some of the innovation happening around securing multi-tenanted data centers, which are going to be much smaller. So, with large kind of colo data centers in the past, you've had these kind of cages, physical cages to separate different tenants, whether it's, a content provider versus, a corporate enterprise. When it's much smaller, it's a much smaller facility, you don't have as much space to do that physical security. So you really have to be quite dynamic. And I think there's some startups which are doing some really interesting work, thinking about how things that used to, that are quite standardized in the data center industry, what they look like now with an edge data center. How do you provide that same level of security to all your tenants in an edge compute location? But I totally agree with what you were saying around, needing to secure things all the way up the stack. I've started to see a lot around this idea of zero trust. So really putting that zero trust kind of guideline and mechanisms, not like you say, not just at the hardware level, but the software level as well. But that's an area I should do some more reading on. So thanks, Cliff, for that nudge. But as always, it's been so good to speak to you. Been a really good discussion. Hopefully, I guess we need to schedule our next one in a year's time to recap what's happening in the telecom space and see where things are going.
I look forward to that.
Great job, Dahlia and Cliff. That was really fantastic, as well as all of our analysts have been throughout the series for helping us dissect the market and put various aspects of the digital transformation under the microscope. Now, I still have the music going. I'm still on hold. Can you believe it? Oh,
we're glad you called. Your call is important to us.
Really? Is it really?
Please stay on the line, and a customer service agent will be with you shortly.
Okay, well, while I patiently wait for my turn in the queue, let's redirect our attention to the MEF perspective with the MEF CTO Pascal Menezes. Digital transformation is much more than moving IT workloads to the cloud. As enterprises move through their digital transformation journey, the building and network edge become critical infrastructure that enables all kinds of new workloads of a distributed cloud. Pascal returns to talk about digital transformation at the edge. Pascal, over to you.
Hello, everyone, and welcome to today's episode on Edge Innovation. What an incredible topic. As you know, the edge is coming in massively, and it's really changing everything we know in around workflow and processes as everything digitizes. There was a really great session this morning from Gunnar, and it was really, really enlightening to see all the use cases for this edge innovation. So today I'm going to cover the MEF perspective on the edge, and let me just go through the details of what exactly MEF is doing at the edge for the edge. As you know, digital transformation is a massive, massive wave of innovation, of massive growth. It's $6.8 trillion in climbing in investments just from 2020 to 2023. Now, under the digital transformation is really network transformation. Network transformation is critical to every service provider and to every enterprise of how the network has to transform to enable this digital transformation wave, and also, more importantly, the edge and what's happening at the edge. In a previous episode, we heard from Azure. Really, Sean talked about these next generation edge scenarios, and also Gunnar alluded to some of these scenarios. But these edge scenarios are very real. They're really affecting every vertical, as you can imagine, from transportation, manufacturing, retail, healthcare, and so on. Every aspect of the enterprise is changing and changing to these new edge scenarios for low latency applications. And I'm going to get into at the very end some really great POCs that we did at MEF to show these edge scenarios are real and real with technology and network transformation. So let's just talk about what is MEF doing at the edge. So we are really involved in a number of initiatives. Basically, number one, as you know, is Sd-Wan. I like to say that our Sd-Wan version 2 is about to be released. And with that, we have also been working on this idea of a universal Sd-Wan for the edge. It's called Universal Sd-Wan Edge. And really what the Universal Sd-Wan Edge is trying to do is provide a minimal interop for the data plane, the control plane, the telemetry plane, the management plane. Now this is very critical because the use case is very simple. With the edge coming in and compute coming in at the edge, many service providers, all the cloud providers, are going to have POPs, and they do have POPs all over the world, and they're enabling those POPs for edge compute. And those at edge compute will actually have to have Sd-Wan services. Now, most of these managed Sd-Wan services have to support multiple vendors at the CPE sites. Most of these subscribers that subscribe to managed Sd-Wan are really expecting to be able to use their vendor of choice inside their enterprise and communicate to any cloud edge or service provider edge for managed Sd-Wan services. And really, a universal Sd-Wan edge specification is really all about that. How can anybody take a universal Sd-Wan edge appliance or virtual function of an edge, apply it at any POP or edge location, and talk to multiple vendors simultaneously? So that's the first time you're seeing a minimal interop standard, and it's coming from MEF. The next area we're doing innovation is on SASE. As you know, SASE is everywhere. It's huge. It's really the combination of Sd-Wan coming from the edge, delivering a cloud security that's enabled at the edge. And basically, all of that has to do with wherever the user goes, their performance, application performance, and their security postures follow them. And really, that's the end goal of what SASE is all about. And with the pandemic, that is the best use case you could ever imagine to enable the ability for users to work from anywhere. So with that, MEF is also doing a lot of work in SASE. We're defining the standardization of SASE, And stay tuned as we release that sometime next year. The work is ongoing, it's moving very fast, and there's tremendous progress in this world of SASE. The other area that goes with SASE is zero trust. As you know, zero trust is becoming very, very common and the buzz of how to do security, cybersecurity, and especially from anywhere. So zero trust, at the essence, enables the ability to have a user, a device, or an application provide an identity and a set of credentials. And with that identity, there's access control that's applied to where that user, device, or application, what they can do and what they can access. So this is very critical, and we're enabling this also at MEF. It's a sister companion spec with our SASE spec, and all of that works together with SD-WAN version 2, Universal SD-WAN Edge, the SASE specification, and now zero trust. So at MEF, we're enabling network transformation in these critical areas, all because of on the edge. We also have been enabling network slicing, and with that, I like to talk about what is network slicing and why is it so important. As you can imagine, most enterprise, wherever the users are, wants to have a great seamless experience to wherever they want to go. And most destinations today are towards a cloud of some cloud-like service, whether it be private clouds, public clouds, so on. Clouds are becoming everywhere, and more importantly, clouds are distributing to the edges. And so the cloud and the use cases of all the cloud IT lines of businesses are being enabled at that edge, and that edge is very critical. So think about slicing is wherever the user is, they can use their devices and applications, get on a slice, whether it be private 5G or any of these wireless technologies, get a wired-like behavior from a wireless technology within their enterprise or their home, and basically get that performance guarantee that continues into the wire area network to the nearest edge, wherever the edge compute is. So network slicing is very critical for this, because slicing delivers really that end-to-end experience of application performance guarantees and security postures. And at MEF, we've just enabled the first slicing framework specification and user specification called MEF-84, and so network slicing definition. And with that, we're adding now slicing profiles. And I'd like to show you exactly a great use case in our MEF POC 132, where you see Spectrum and Juniper and Adva and Equinix deliver a user experience where the users in the stadium, and they can get different viewpoints because cameras are located throughout the stadium picking up different viewpoints. And that's then being analyzed at the edge by these AI, ML, deep neural networks. And basically, it's then processed, and users can decide what they want to see and how they want to see it. Additionally, all that video processing is shipped to the data centers, and then at hotels, as you can see in the diagram, from the resort hotel, in this case, Waypoint Resort A, they have an end-to-end slice. And so users in that hotel can also get a point of view of how they want to see that game and how they want to see it. And so that's all enabled by slicing. And additionally, in the Wayport Resort B, they're using instead SD-WAN, or SD-WAN 70.1 specification instead of slicing. And you'll see within our work, SD-WAN and end-to-end slicing does work together, and we'll demonstrate that in future specifications of how slicing and SD-WAN works together. Now, additionally, we're also releasing our APIs. We have our East-West APIs that was designed for Sonata between providers. We are now releasing that in our SDKs to the enterprise. What that means is more and more enterprises want to be able to access the edge, not only for SASE and SD-WAN services, but they also want to utilize that edge compute for their own application. And with our Cantata APIs facing the enterprise and Allegro operational APIs, we enable this. And there's no better use case than our POC 136, which actually shows the idea of an application optimized SD-WAN, where you see, for example, in POC 136, you have the DevOps guys who are really taking care of the applications in a microservice distributed model of applications that lives at the clouds or at the edges of those distributed clouds. And then you also have the NetOps guys who are programming the network for SD-WAN, and they're allowing what a gold service is, or a platinum service, or a bronze service, and so on. So now what happens is basically you don't have to have the NetOps guys program on a per flow application basis what needs to happen on performance guarantees. The developer and the DevOps just has to say in his code basically that, and runs on microservices, that this is a video set of flows. And basically what will happen is that will automatically, through a set of APIs, communicate to the Sd-Wan environment and automatically say that these set of flows are video and should be treated with the video kind of performance guarantees like low loss, low latency, and so on. And that would be the gold service, for example. And when another service, for example, text or messaging, doesn't need that criticality, it can use a lower service like a bronze service. And this is all done by applications programming the network. What SDN and SD-WAN allows is the ability now of applications themselves programming the network to what they want from the network. And this is exactly what is the essence of where we're moving to the edge of applications want to be able to access the edge and get information from the edge, not only processing from the edge at low latency, but also the ability to program that edge with all kinds of APIs. And at MEF, we're enabling that with our Cantata and Allegro set of APIs. So with that, I want to thank you for taking your time with this session. And this is a fabulous episode. And with that, thank you so much and have a great day.
From under the microscope to MEF's point of view, thanks Pascal for a more comprehensive look at how MEF standardization enables network service providers to create on-demand, complex, and customized edge-based services with a variety of ecosystem partners. What a very nice finish to the first part of the show and segue into the break. I'm just checking. So let's take 3 minutes to grab some refreshments. I mean, we are at the bar, right? We'll meet right back here for our deep dive with experts from Comcast and Sienna Blue Planet.
Thanks for holding. Postal code, please.
9-1.
Thank you. Hold, please.
No! I'll see you right back.
Digital transformation. Massive boost in network capacity, scale, resilience, and performance. Transforming industries, enabling new, innovative applications and business solutions. MEF 3.0 services are critical enablers of this transformation. Service providers rely heavily on robust, standard MEF underlay services, including carrier Ethernet, optical, and IP. When enabled by MEF LSO APIs, they dynamically support the delivery of overlay services including SD-WAN and digital services such as SASE and Zero Trust Security, all coming together at the rapidly changing network edge to deliver a frictionless experience from enterprise to cloud. Supporting the adoption of MEF standards are MEF certifications for service providers, technology providers, and industry professionals. Widely recognized and respected credentials.
It's definitely accelerated a lot of different aspects of our business. The bigger initiatives around digital transformation, cloud, mobile first, and SD-WAN really picked up steam.
I cannot overstate the importance of the certification. And MEF has a huge role to play in this. It has taken a much more difficult task and made it simple.
MEF 3.0 certification enables service and technology providers to demonstrate conformity with the industry's highest service standards. Certified technology suppliers can accelerate onboarding into service provider and enterprise networks, getting to revenue faster. Service providers improve their competitive positioning with business customers by using common terminologies, reducing feature confusion, and demonstrating compliance to critical service functions.
We see a real value in in bringing this type of certification to our customers, and I'd encourage everybody in our ecosystem, every provider, to actually pursue this effort.
Building and scaling networks for digital transformation requires a myriad of contemporary skills. MEF certification for professionals defines and validates the expertise required to deliver revenue-generating services central to this requirement. Individuals with these skills are uniquely positioned for career growth and advancement. MEF certifies professionals for services including Sd-Wan and carrier Ethernet, with SASE on the horizon.
Welcome back to MEF Infinite Edge, Episode 8. If you're just tuning in, we're talking about enabling the competitive edge and one of the major drivers of business today, the customer experience. Oh, and yeah, I'm still on hold with customer service. I'm kind of getting used to the music now. It's got a good beat. Anyway, it's time to jump into our first of 2 deep dive sessions of the day. Recently, I had the privilege of speaking with Yulia Duryea, Product Management Director at Comcast Business, and Kevin Wade, Senior Director and Product Marketing Team Leader, Blue Planet, a division of Ciena, about how application-centric traffic steering enables for deeper granularity, ease of network management, and drives outcome-based decisions. Here is what they had to say. And I'm excited they're both here with me right now. Thank you, Kevin and Yulia, for joining this deep dive. It's been an exciting time recently, not just in the customer experience realm of what we're talking about today, but this is the time of the Olympics. Kevin, have you been watching? And if so, do you have a favorite sport, something that's really intrigued you or been excited about with the Olympics?
Yeah, definitely exciting. I'm a huge Olympics fan myself. It's hard to pick an absolute favorite. Overall, I really enjoy the less popular sports, things like badminton and swimming. And I'd say if I were to pick a favorite, it would probably be swimming and then the relays in particular, because I enjoy the the dynamic within the teams themselves, a lot of excitement there, and then the sportsmanship and the competition across the different countries. So the swimming and the relays would be my absolute favorites.
It's been incredible. Such a good show of sportsmanship. You're right. And Kevin, where are you joining us from today?
I am based in Northern California, a little bit north of San Francisco, a small town called Petaluma up here in Sonoma County.
In Sonoma County, not a bad spot to be. And Yulia, sorry, where are you joining us from?
I am joining from Denver area, from Colorado.
Doesn't Denver have like 320 days of sunshine a year? There's a good stat like that, right?
It does. It is one of the sunniest states in the country, so we love it out here.
I'm a little jealous here in Columbus, Ohio. And how about yourself? You've been watching the Olympics? Favorite moment?
There are so many. It's so hard to pick. Just seeing all the sports and the sportsmanship, and even sports that I'm not as familiar with, such as weightlifting. I was watching with my kids the other day for like 2 hours, and it's probably one of the first times ever, and I enjoyed that as well. So it's been really fun.
It's been great, and I hope everyone's watched and enjoying it as well. I'm an Olympics junkie. In fact, I've been to 2 of them, and I plan on going to Paris when the next one hits. So if there's someone watching from Paris, I may need a place to stay. Is that all right? I look forward to maybe Airbnb in your apartment or your flat. All right, let's get this started. We got a great deep dive ahead, and I'm going to jump right in. Kevin, tell me, edge compute has become a big topic for network service providers over the past year or so especially. What's the reason for the growing interest?
Yeah, and I would agree that the discussions, industry discussions on edge compute or edge cloud definitely ramping up, and there's, I think, a couple reasons for that. The first of those would be 5G is becoming more real, right? And 5G, the best way to think about it, at least as far as I'm concerned, is that it's an access network upgrade that the access, broadband access that both individuals and residential customers and enterprise customers will be able to leverage for higher bandwidth and lower latency. So that as that becomes more prevalent, it makes technologies like edge compute more real and more near term. But also there are a newer generation of services that service providers like Comcast are making available that have some responsiveness associated with them and self-service capabilities, things like Sd-Wan come to mind. That interest and that evolution of these new types of digital services are also spurring interest in edge compute. And then finally, I would say the evolution of cloud native applications, applications that are really optimized to run in what you can think of as public cloud infrastructure, or even some aspects of it in private cloud, also kind of make edge compute, edge cloud more real. And I would say even maybe one final thing is that if there is one good thing about the current pandemic, it's that it has proven the success of the cloud itself for supporting, business critical type applications. So that aspect of the cloud being proven out as effective, even capabilities we're leveraging today in terms of everybody working from home and leveraging cloud-based applications for collaboration like we're doing here. That also is, I think, driving this interest in leveraging edge compute capabilities from a service provider perspective. So a lot of different facets that are coming together that will enable a new generation of services over the next couple of years.
No, you're right. And I love how you brought out the positive in there as well, and that proof of concept of what's happened for those critical systems. And you just mentioned service providers, and I think they play a big role in delivering these new edge services. Who else do you think is involved?
Yeah, it truly will be an ecosystem, and it has to be an ecosystem for edge cloud, edge compute to work. The service provider does play a critical role. They own that last mile infrastructure and oftentimes much more than that, but certainly that critical last mile. And overall, I think we'll own the end-to-end service, so to speak. But as I mentioned just previously, these the public cloud providers, the AWSs and Googles and Microsofts of the world will also play a big role, because they'll own and operate these distributed cloud resources that are out in these new edge data center sites. So they will play a role, but those cloud native application providers will also provide a role. I mean, that will be really the new element of this, and that these new cloud native apps will learn to coexist in this hybrid infrastructure, if you will. And then finally, the automation and networking vendors also will play a role in as far as the hardware, and then the automation software that's managing the service needs to be open and scalable and flexible to support this multi-technology environment, if you will. So certainly, yeah, a lot of pieces coming together at the edge. What you can think of as an ecosystem, and a lot of players involved. It's not just a service provider anymore. They will be working in an open way with all of those different participants.
Kevin, spot on. I see the exact same forces that are driving the event of this new edge computing era. But in addition, we also see the Internet of Things, right? They're really all these devices that connect to the internet for either receiving information from the cloud or delivering data back to the cloud. And all of them, many of those devices really generate an enormous amount of data during the course of their operations. So that really is a driver, because potentially the quality of that operation could suffer. And another point that we really see quite a bit from customers is these new applications that require real-time computing power, which I feel that requirement of real-time computing power is more is heavier and more prevalent now that we are redesigning applications either for SaaS or just to further improve the quality of those applications.
Yeah, very true. That's exactly that responsiveness, I think, that I think customers are looking for, and whether those customers are things like enterprises or applications, or like you said, these new devices. I mean, smart refrigerators or thermostats, probably more likely. Other types of devices that we're carrying on our persons, so to speak, all are going to be generating data. Much of it that needs to be processed closer to those different types of customers. So yeah, you're absolutely right.
Thanks for jumping in, Yuli. I'm going to jump back to you for a second, if that's all right, and help me understand, how is edge compute different from current common architectures? And will edge compute take over traditional architectures for most applications? What are your thoughts?
John, so there's 3 common places today where you could place your applications. The traditional approach is to really host that application in a server in your own data center. So this data center is usually within your WAN. It's just another node on your network. So traditionally, that's what we did. And then a few years ago, companies increasingly would instead choose to host the application in the cloud. And with a cloud service provider, either AWS, Azure, Google Cloud, etc. And the reason for that is there's many reasons why cloud has been really adopted from SMBs all the way to large enterprises. But you have the flexibility and the elasticity of the cloud. You have the reliability that the cloud provides, right? Really the backup and the disaster recovery. You have the security, you have the pay by the drink concept versus a kind of an NRC type of or CapEx type of investment upfront. And all of this is basically and also removing, I guess there's also the removing of the hassle of really having to maintain an equipment. So think of like either buying a car and potentially paying it off within 5 years and then keeping it for 10 years, or leasing it and every 2 or 3 years getting a brand new car, which sounds nice. I haven't done, but I should Just think about it. But the trade-off with the cloud really is that now you have the potential of adding latency. So here's the user and here's the cloud, and there's potential back and forth trip that you could potentially add latency that would impact negatively the quality of that experience. And then the cost. The cloud does charge you for anything that comes out of it. So the question is, how long is this end user journey, right, from the user to the application? And does the application require real-time compute? Right. So how long is the journey, and does it require very intense compute power? And it's ultimately, right, do you make the bid or do you transfer the bid? And you kind of weigh up and down. So what has happened is that really it's the cost of compute versus the performance of the data transfer, the performance and the data transfer, right? So what edge computing is really doing is that it's turning things around. It pushes the application closer to the user, right? It brings computation and data storage closer to the devices where the data is being gathered. And hopefully it is minimizing that latency, right? It's improving the customer experience. Is it right for all applications? I don't think so. I think it's really application by application and what the application needs to do in order to provide the best experience.
All right. Well, then what role do you feel, if any, does SD-WAN play in enabling edge compute? How will that play in?
So Kevin mentioned SD-WAN, and I really think that SD-WAN is part and parcel to enabling cloud compute. I'm the SD-WAN product manager, so obviously I will say that. But SD-WAN is about connectivity, right? No matter where the compute resides. So it frees the customer to put their compute where they need it, to have the applications where they need it, and to have the users where they need to be. So how would SD-WAN help? Well, number one, SD-WAN brought application awareness. So we're able on the first packet to recognize what exact application it is and to be able to take an appropriate action based on how critical it is for the customer. SD-WAN also has brought to the front dynamic traffic steering, right? So think of split tunneling, think of different applications. And if it's an application, let us say that it is Vonage or some kind of SaaS voice application, SD-WAN would recognize it will push it through potentially a gateway in order to ensure best performance from an application perspective so that the code doesn't drop. And then it will go to SaaS. If it is Microsoft Office 365. Well, Microsoft, that is a cloud native application. They have very clearly stated that for those applications, we should not put them on the SD-WAN tunnel. We should actually be able to put them natively because within the protocol, they have built in that capability so that when you're on Teams meeting, when the Teams meeting goes down, it automatically reconnects you. You don't have to go. I mean, I always panic when it happens, which is pretty, it's pretty rare because I do have SD-WAN at home, but still it is, it just reconnects you. It is seamless for the user, right? And then the self-healing, right? The fact that SD-WAN can basically poll the health of each of the different circuits. They can determine which is the best circuit and place the packet on the right circuit. So all of that really, really helps and enables the user to place the application where it needs to be. And then take the evolution of SD-WAN into SASE and bring all of these security components, whether it's network security, whether it's content security, whether it's device security, right? We have to secure those devices and we need to understand who are you, which device are you trying to access from, which application are you trying to access from, do you have access to that application? Should I give you access to that application from this device? So all of this, that was zero trust networking, but all of this basically SASE has taken SD-WAN and all of these different style of security and has put them into one whole kind of bundle, which really allows our customers to be able to say, okay, let us help you with your applications based on how you would like to run your business.
Yeah, and if I might chime in, John, quickly. So I think that's spot on, Yulia, and really where I think SD-WAN has kind of revolutionized things, relative to legacy services, if you want to call them that, is that both that visibility that your customers are given through the SD-WAN dashboard, so to speak, at the application layer, right? That they want to understand the relation of their applications to their network services, and SD-WAN gives them that visibility and that responsiveness that is only getting them to the point where they want more, right? And that's what edge compute will allow them to do once the network infrastructure is built out with 5G and other upgrades. So yeah, SD-WAN is certainly an inflection point in terms of changing from the old world that was just bandwidth, just connectivity, to the new world where you have visibility and at the application layer.
Visibility and control, right, Kevin? Because you're able to see the data and then you're going to really take an action. And as a customer, you can go through your digital experience GUI and you're able to make application level decisions and policy level decisions. I mean, amazing.
Yeah, I mean, and that's why, and you said it a couple of times, I mean, customer experience is key, right? And that is, customer experience and what is fundamentally different from the old world. Old world, the network goes down and you call, and then it takes how long it takes to get that service back up and running again. Now you have visibility and control. So you're absolutely right.
I'm going to dig into some of the challenges in a sense then. We mentioned some of them, but what kind of challenges, Kevin, will network service providers face operationalizing edge compute-based services?
Yeah, and there will be some challenges there, but there are certainly solutions to said challenges. I think the biggest one, the biggest difference from some of the services that are available today that will exist with edge compute is the services will run over this multi-technology infrastructure, several different domains. We have the public cloud. That's where folks like AWS and Azure and Google Cloud live. You have the network infrastructure and multiple segments of the network. Yes, it's going over the 5G access, but there's also a metro and a core network. In terms of this end-to-end service, there are these different vendors involved when it comes to like the applications themselves. These cloud native applications, including even many SD-WAN solutions are cloud native. So for a service provider, figuring out how to manage the services from end to end that goes across that, by definition, heterogeneous infrastructure, it's a little bit different, right? And because of that complexity, you can't use the legacy OSS solutions, operational support systems that have been used to support things like Sonnet and TDM and T1. So many of that still exists out there. You can't use that OSS and those systems to support these new types of services, edge compute type services, but also things like slicing. You need a new generation type OSS that is built and designed for automation, because automation really will require, these types of services require less and less manual components to them. And so overall, though, I think, just because of the complexity of this end-to-end offering across these multiple domains, service providers are rethinking the types of systems they're putting in place to support them overall.
Yuli, anything to jump in there or no?
No, I think Kevin really hit it out of the park this time.
He hits it out of the park a lot. He's right on top of this.
Yes, he did.
Well, he does. Well, then I'll jump. I'll jump back to you anyway. Let's talk use cases. Can you share a few use cases where edge compute solved the customer business problem, and even go deeper? What were the customer desired business outcomes and benefits of that?
Yeah, sure. I would love to. I think this is where the field is still pretty fresh. We still don't know which use cases are going to be real and which ones are going to be lasting. But there's certainly a few that come to mind. I'm not going to go with the self-driving cars that we have all heard. I'll go more real and something that we really, as SD-WAN product manager, I talk to these customers every day, and that's retail. So when you think of retail, right, you think about hundreds of locations, same footprint, very price conscious. As a reminder, they were the first vertical really to adopt SD-WAN. And their most critical applications is SaaS optimization for payment applications. It's point of sale. It's online ordering now with COVID. That's absolutely critical that they can get every online ordering because that's expansion of their revenue. And then it's VoIP and UCaaS. They have 1 or 2 phones that need to be able to pick up the phone and take that order. So what they're looking at, in addition to those items, there is really a push towards personalization, right? Towards bespoke promotions, right? However, any type of personalization does consume a lot of compute cycles, so that we have to keep in the back of our minds. They're also looking at salespeople, right? Walking with digital tablets, automated checkout options or self-checkout at Costco, right? Store staffing analytics. And ultimately, they're really looking at kind of consolidating the online experience with an offline shopping experience. So when you take all that into account, which is a lot, but they're really going through this digital revolution, the entire vertical is. So think about point of sale transactions, right? So you can do them at the point of sale, or you can do them up in the cloud. So at the point of sale, they will be faster, but it is definitely not as secure. And what if it goes down? Right? If you do them in the cloud, then it's going to take you a while to get to that transaction. There could be latency, and there's a lot of potential points of failure up until you go there and come back. So what if you had in an area, let's say if you are, I'm in Denver, so let's say in the Denver area, for all of the different, chain stores, you have one kind of centralized cloud compute gateway. And that is where it's really short distance. So you're within, 5 milliseconds max, right, to go there, process the transaction. You don't have to invest in compute in all of your different stores, right? I mean, if you think about Starbucks, which if it's Denver or if it's New York City, I mean, it seems like there's a Starbucks in every single corner. That could get quite pricey. It's really not very smart. But if you could consolidate that into the middle mile gateway and process those transactions there, now even better, if you could actually kind of combine that processing with a targeted promotion. Oh, I know that you're John, and I know that you came to the Gap store 3 times in the past month, which would be different than if you came into the store 3 times in the past year. Here is the type of promotion, how I need to be able to look you up extremely fast and be able to give you something that's very, very personalized. So that's a really, really great example that we have seen where really cloud compute plays a big, big role, or it could certainly within those type of transactions. Another example is video processing. So video processing, extremely intensive in compute power, right? So you have many, many different videos from either remote locations or maybe even stadiums. We just talked about the Olympics, but even think about like sports. We actually have a customer who transmits videos from sports from kids, so that grandparents, especially now with COVID, right, they couldn't go to attend any sporting events. Parents sometimes, right, the mom is working late, etc. So all of that, and when there is one feed, it's a lot easier. But when there's hundreds and thousands of feeds, depending on where the origin is and where that resides, it could really bring it down. The quality, I mean, latency is probably the killer of video. So the solution would be edge computing hardware and services, right, to help really with a local source of processing and storage for many of these systems. So that's another example that we have really seen that works very, very well, and where we have been able to apply this new, not new, but relatively new edge computing architecture, and the customer has been extremely satisfied with it.
No, thank you, Yulia. Great use cases. And you're right. After this, I'm going to run to the Starbucks around the corner in Olympic-like speed to get mine get my little fix. All right, Kevin, I have one more for you. What are some of the important standards initiatives related to edge compute?
Sure, yeah, and there are a number, right? Just like with the example I gave of all these different entities being involved in delivering the ecosystem-based approach for delivering these new types of services like Yulia was just describing, and across all these different segments of the network, as you would think, there are a lot of different standards involved as well, right? Because different folks look at different pieces. I would be remiss to not lead with the role that the MEF plays here, right? And in that respect, I think a couple different initiatives on the MEF side are involved. The first of those being LSO, Lifecycle Services Orchestration, that looks across, the role that orchestration and automation plays in delivering the end-to-end service and ensuring a good customer experience. So MEF, LSO, but also Sd-Wan, which will, as Yulia and I were saying, kind of will lead into an evolution towards these new types of edge cloud, edge compute services. So that they play a critical role. But also, there's a new organization out there, newer, I would say, that is driving the evolution of cloud native services and capabilities called the Cloud Native Computing Foundation, CNCF. So they play a role. And then the ETSI organization, which looks after globally a number of different telecom standards. They have several that play roles. NFV it plays a role. Something called ZSM, Zero Touch Service Management, very aligned with the LSO concept. And then even more recently, they look after the actual standard called MEC, which stands for Multi-Access Edge Compute, or mobile edge compute. I think they're trying to change the name there, but the MEC standard is probably the most relevant. And then there is a tight alignment and collaboration with 5G as well. So 5G has a set of standards for things like slicing that all are fit under it's 3GPP. Is the standards organization that is related to all things 5G. So a number of different standards organizations all playing a role. The good news, though, is that all of these organizations are, in fact, working with one another, both to make sure their different standards initiatives are complementary rather than competitive, and in fact, take use cases like the ones that Yulia described and use those to make sure all the integration points are well defined, because they want to simplify the rollout and the evolution to these types of services. So that's probably the good news, that in the days past, standards used to be a bear, right? Different vendors and service providers used to almost use them to hash out their own strategies and compete with one another. But now it's more of a collaborative environment. Again, an example of people embracing openness and ecosystems. So everybody's playing nicely together in the sandbox, so to speak, and our customers will ultimately benefit from that.
Kevin, thank you so much for sharing all that. Yulia, thank you for sharing so much of your time. This was a great deep dive. We talked architecture, we talked experience, we talked standards initiatives. We even got a little bit of Olympics and Starbucks in there, which is kind of a perfect transition. You two, I'm going to see how quick I can run, get myself a coffee, and get back here before the next deep dive. And in the meantime, hopefully that incredible host may have a word or two for you. But really appreciate you two sharing your time. Any final comments?
Not for me, John. Thank you, and let's all of us enjoy the Olympics for another couple of days here. So I'm looking forward to that.
Yeah, same here. Thanks for having me.
All right, check out the speed. Here we go. Thanks everyone for joining this deep dive. My name is John, and I will see you shortly. That was great stuff. Thanks to Yulia and Kevin for the interview and for sharing their thoughts on the differentiation and impact of app-based traffic steering on user behavior and the user experience. And I got my coffee in time. Hey, if you have questions or comments for our speakers, please feel free to post those in the chat.
Customer service, thank you for holding. How can I make your life better today?
Finally, I'd like to change my service.
I can help you with that. Postal code, please.
91234.
Great. 91234.
Hey, I'm going to need to take this, but for our final look at today's topic, we're taking a deep dive with experts from Cisco and Equinix. During the interview, I asked them about automated and dynamic services all the way to the edge. Here's what they had to say. I'm here with Charles Eckel, Principal Engineer, Global Technology Standards of Cisco, as well as Dawn Howell, Principal Interconnection Product Manager at Equinix. Are you both coffee drinkers? I just ran in with mine.
Oh, definitely.
For sure. Yes.
Tell me this. Are you one that does it at home with one of the fast make machines? Are you the drive-through brew type? Or do you make like the super fancy ones at home? What do you think, Charles?
Oh, so my coffee's definitely not fancy. Just, black is perfect for me. But, what I've found is I do still like good, good coffee. And French press has really become my go-to because, whether I'm home, I'm traveling, you almost always have easy access to hot water. You just bring some good grounds and, you can make really good French press, just about anywhere. So that's kind of my go-to when I need to make sure I'm, taking care of myself that way.
That is excellent. How about you, Dawn?
Well, I used to have a manager that actually roasted his own coffee beans, but for me, I just like to brew a big pot of drip coffee for the whole family because we're all coffee drinkers.
We're all coffee drinkers. Well, both work, and I'm glad that we've all had it today and can jump into a deep dive number 2 of this episode. So, Dawn, why don't I jump right in and bring it to you? How can network providers move faster to turn up and offer services all the way to the edge with minimal risk and maximum value?
Yeah, so a key factor for minimum risk and maximum value is the decision of buy versus build. It's no secret that network providers play a key role in the world of digital transformation. Enterprises are moving to the cloud at a rapid pace, and network providers have a lot of responsibility to enable these enterprises to consume network services the way they consume cloud services. And with the shifting digital landscape and increasing need for automation, network providers need to think hard about buy versus build. Making that decision is critical to this acceleration. For example, at Equinix, we're developing products that can enable network providers and partners to quickly spin up infrastructure such as virtual network functions, compute, and storage with little to no capital investment. It allows the network providers to focus on what they do best, such as Sd-Wan, SASE, and even the underlying transport and automating those network services. But that, combined with the ability to spin up compute, storage, and security services at the edge, allows them to deliver powerful automation solutions to their customers.
Thank you, Dawn. And you mentioned some of the factors, and I know that some people want to really make this move quick. Keep going for a moment on what factors and standards you believe will really accelerate this move.
Yeah, so I think accelerations of the move to the digital experience will be driven by standards around deploying edge services in any location by any provider quickly and simply. Make it easy to consume, integrate, and pay for these services with models that can be adopted by any number of service providers. These services will need to span a broad variety of use cases, 5G, AI, Edge, IaaS, PaaS, and IoT for both the provider and enterprise edge domains. Some factors to consider include focusing on building infrastructure and applications that have zero-touch provisioning, operations, and lifecycle, which in turn reduces OpEx. Focusing on a finite set of configurations in order to reduce complexity. And focusing on the ability to support multiple workload types such as VMs, containers, microservices, etc. MEF clearly sees the importance of all these factors and is doing some great work to accelerate the creation and adoption of standards around edge services with their Sonata and Cantata work.
Thank you, Dawn. I appreciate that so very much. Charles, we're going to jump over to yourself. I've got the French press kind of brewing here for you just so you're ready and I'm ready as well. But more importantly, I want to understand what important building blocks does MEF provide and what more do you feel is needed?
Yeah, so MEF is really all about defining standards for managed network services, beginning with carrier Ethernet, then IP services, and more recently for SD-Wan services. And we know SD-Wan is really an overlay service on top of using various underlays, and those underlays may in fact be MEF services such as carrier Ethernet and IP services. And those standards are really the key building blocks that are needed for service providers and subscribers and partners to all speak the same language when they're talking about any network service, and specifically for SD-Wan service, where there was so much of a disparity in the way different solutions were being brought to market. So MEF standards have really helped a lot with the acceleration of SD-Wan in general and just getting mass deployment and adoption of SD-Wan services. So what's really needed, though, to take it to the next level is we want to be able to automate these services. And for that, we need APIs. And within MEF, there's a lot of great work with the LSO reference architecture around APIs. But more specifically, we need APIs in the context of SD-Wan and APIs that will help the SD-Wan network discover and understand applications as they come onto the network, not only for traditional applications, but really more specifically for cloud native applications as well.
Well, and I want to go deeper again because it's a deep dive, because we hear a great deal about the need for the automation you mentioned to handle demands of dynamic application workloads. But how are you addressing that?
Yeah, so we're really one of the things I'm doing, Cisco's doing, that MEF is doing, is we're defining APIs to fill that gap that we said is needed. Not just SD-Wan service APIs in general, but APIs that are needed to augment that application awareness. Application awareness is so important; it's a critical part of SD-Wan. But especially in today's networks where you have new applications come onto the network and ramp up and ramp down very quickly, that works great in, say, the cloud, network. But in order for the SD-Wan network that they're being transited over to understand them and be able to handle them, it needs to know what they are. So we're defining APIs that help enable that to happen. And this is being done through collaboration with the Kubernetes community and the Linux Foundation, with other standards organizations such as IETF, and of course in MEF. Now, open source code and open APIs, those all help a lot. But what's really needed there is that collaboration, true collaboration across these groups to make sure that the needs of all the different stakeholders are involved, so that what's defined isn't just as the network operators envisioned it, or just as the application developers, envisioned it, but really as, that it meets the needs of everyone. And so we have an incubation group that we've defined within MEF, and we're tackling exactly this problem of defining SD-Wan APIs in the context of the LSO architecture, and specifically so that we can discover cloud native applications as they come on the network and understand how to deal with them better.
Thank you, Charles. That was a great and much deeper dive, which is awesome. Dawn, don't fret. I've got your coffee coming along too. I see you both still don't have any, but hopefully you can share. How is the move to cloud native, secure, and automated services changing our customers' need?
Yeah, so we see a big shift in customer requirements and customer needs with the move to digital transformation. I mean, first of all, and clearly more virtual, less physical. They're looking for touchless, asset-light methods to deploy and operate network services and infrastructure, and they are seeking the most and most likely prefer virtual equivalents to what was previously physical assets. They also want choice at the same time. They want to exercise opinion on technology choices they feel important for their digital advantage, whether that be the choice of operating software, edge locations, where to deploy virtual versus physical, etc. And they want those choices to bring additional value. Many customers will continue to want engagement with an ecosystem of partners who enable technology adoption on the customer's transformation without forcing huge disruptions. That's very important. Customers clearly want self-service. Their expectations about digital on-demand channels from purchase through support have increased steadily. The customer experience needs to be easy enough for self-service digitally at every step, starting really before anything's ever purchased. Customers will buy in the future before we or their partners even sell. They're looking for simplicity. They seem to want to push complexity from their value chain these days to the provider. Things like contracting, logistics, compliance, etc. Customers don't want to deal with these complexities. They simply want to spin up and spin down services that are needed when they're needed. So we see an additional persona in our buying behaviors, more engagement from the DevOps persona. So, and these are often lacking DIY networking backgrounds. So we need to be able to go beyond negotiation of just bandwidth connections to areas like traffic optimization and network threat prevention. And then last but not least is integrated commerce. Customers like a one-stop shop consumer experience like shopping Amazon or the Apple App Store can attest to. Customers increasingly value integrated transaction experiences orchestrated for them across vendors.
Well, that's great, Dawn. So, Charles, I'm going to kick back to you. What's been tried in the past, and what do you feel is different here?
Yeah, I mean, that's a great question, because our networks have had lots of powerful standardized capabilities for years. Working at Cisco, I've seen those come to market. We're not taking the foot off the gas in terms of making our equipment, more powerful. Of course, standards have always been important to Cisco. So, I mean, that's been the state of things. But the challenge is really to use those capabilities in real networks is really effectively. So the communication between application developers and network engineers, I mean, that's been a challenge, for as long as I can remember. In the standards world, but in other places too, they really tend to just talk different languages. And the application developers are very clear that for the most part, they don't want the network messing with their traffic. And then network engineers are like, well, we can help the application work better, and but at the same time don't want the application developers messing with their network. So, that's been tough. Now, SD-WAN definitely helped out and is helping out a great deal here, because SD-WAN is all about the applications, right? The needs of the applications are brought, to the forefront. So that's a big step there. But more is needed. And that's where defining these mechanisms, or at least what our solution proposed is to let application developers annotate their applications. So this is like built into their application as they're deploying it, that they can describe a bit more about their application. What does it need? Is it business critical? Is it a real-time application? Does it require low latency? Does it need a lot of bandwidth? And then these can be provided as part of the application description to the network, to the NetOps guys. And then on the NetOps side, those folks are able to look at that and decide how best to try to meet those needs of the applications, to map the application onto their network, to optimize the handling and use of their underlay services within their SD-WAN to meet the needs of those applications. So that loose coupling between the application needs and what the network is actually doing, and doing that in a kind of a collaboration across the open source community with Kubernetes and the standards folks. That's really what's new here, and what I think is going to help solve this problem for us.
Well, love that we can solve the problem, but what's the current state of this work, would you say? And how does one learn more? And so importantly, how does one get involved?
Yeah, great. And I'm really glad you asked that. Because the way this all started was actually as an open source project within the Kubernetes community called Cloud Native Sd-Wan. And this project was really tackling that specific problem of applications within a Kubernetes cluster as they come onto the network. How can the Sd-Wan discover them and provide optimal network services for them? So you have that open source project. And then what we did, we have a POC, a proof of concept within MEF. It was part of the proof of concept showcase done this year. And it was called Application Optimized Sd-Wan. And that was a collaboration with Cisco, Engena, and Equinix. And that's actually when Don and I first had the privilege to start working together. So that POC was very successful. And as a result of that, we were able to get approval to have a new incubation group within MEF to tackle this problem space very specifically for cloud native SD-WAN applications, to define LSO APIs for SD-WAN that really can help optimize how we deal with them. So that incubation group is up and running. Our goal is to come up with a project proposal and to have that approved so that we'll have a real MEF project defined behind this. And we're meeting weekly on Mondays at 9 a.m. Pacific time. We moved our calls to try to make it more time friendly for more folks. So it would be great if you join us there, learn about what we're doing, help us make it work better. Like I said, this is really a collaborative effort. We need the opinions and ideas of all the stakeholders in there. So I hope you join us.
That would be great. I hope some people join as well. Now, I've had the French press. Oh, I lost the top of the lid on that one. I got the drip going now, and I come in with store-bought. I'm getting a little jittery, to be honest, but it gets me excited because we want people to get involved, and I got to taste that one for you, Don. I'll put a little bit of flavor in there. Whew. It's going to be a good rest of the day. Charles and Don, I'm very excited that you could join us and be sharing this deep dive with us today on our 8th episode of the Infinite Edge series. Any final comments while I get one more sip of Don's fresh brew here?
No, I mean, that coffee looks great. I had a ton of coffee before this. So now for me, the challenge was just, I guess, getting my mouth to keep up with my mind so it didn't overrun it. But, this has been great. I really appreciate having this opportunity to meet with everyone in this format and talk with Don and yourself, John. And, I look forward to continuing this work. There's a lot to do here. This is an exciting space. It's moving fast, and we've done a great job meeting online in order to move this work forward. We need to continue that. And I really look forward to being able to travel and meet in person and continue to move this forward because it's an exciting area.
Yeah, lots to do, exciting times, and I really look forward to seeing everyone live, hopefully in the near future.
Me too. Thank you, Don Howell, Charles Eckel. Whew. All right. Appreciate your time and your talents. It's time, I think, we check in with the host, see how he's doing on hold. Maybe he's a little less caffeinated than I am at the moment. We'll see you in a second. No, the last 4 of my Soch is 5789. 5 and then 789.
Hold, please.
A special thanks to Charles and Don for closing out our show today. great insights on ever-increasing demand for digitized network services that are cloud native and how customers procure infrastructure and network services. From those two, and lots of food for thought from all of our speakers today. From Gunner's perspective as an executive of a major industry player, and market insights direct from the analyst corner, wherever it may be, to an update on MEF's work and our deep dive of the day, our experts succeeded in pulling back the curtain to discover the magic and competitive edge of creating great customer experience. And can I just say once again, we owe it all to the extraordinary support of our sponsors. A very special thanks to them for also making the content available on demand on this platform. Make sure you check out their sites on this platform as well after the show for additional content that may be of interest to you and opportunities to connect directly with them and one-on-one with each other right here on the site. And thank you, our audience, for joining us for another episode of the MEF Infinite Edge series. Don't forget to tune in to our episode 9, Innovative Security Services, Is My Network Secure? Airing September 15th. It's our final episode of the series, and you don't want to miss the great content and fun surprises we have in store for you. Until then, stay safe, and we'll see you back here as we continue to explore the infinite possibilities of the digital world across the network core, the cloud, and as always, the edge.
So sorry for the delay and thanks for holding. Like the message says, your call is very important to us. The last 4 of your social security number, please.
Oh, 5789.
Great, 5789. Thank you. I have your account, sir. You would like to make a change to your service?
Yes, I would.
To add or remove?
Well, I think I just want to remove it now, to be honest.
Oh, I understand. Hold, please.
You've reached customer service. Our office is closed. Please call back during our new business hours, Monday through Friday, 2 a.m. to 2:01 a.m. Patagonia time. Thanks for calling.